So on this statistics, the one I picked out here, there's finding the mean, median, mode, and standard deviation. Probably have you do some of that. But the one I picked out to review this page is normal distribution has a mean of 72 and a standard deviation of 3. So yeah, I may very well have you compute a mean and a standard deviation, so be sure to review how you find those. The mean is just the average, and then standard deviation, there's a little procedure to follow, but it's not too bad. Because I think I do have find the mean and find the standard deviation is one of the problems. So hint. But on this one, on A, 9A, based on the empirical rule, what percentage of values in this distribution are between 69 and 78? And again, we're using the empirical rule. And remember, on the empirical rule, there's three numbers, three values: 68%, 95%, and 99.7%. You have to recall there. I think it always helps to draw the picture. Let's draw the picture. Normal distribution, so that's the bell-shaped curve. What goes right in the middle? Mean, 72. So 69 would be down here, and then 78 a little further out there. And then on the percentages here, they're based on how many standard deviations you are away. So 69, so to get to 69, a standard deviation is 3, so that's one standard deviation away. And so that's the 68%. However, the 68% goes from one below to one above. This is just one, because that one's not 1. This one's 2, right? 78 would be 2 standard deviations. 1 standard deviation would be 75. So that's 2 standard deviations. So that's a different number we're dealing with over there. So this is just half of 68%. So that right there is 34%. This over here is 2 standard deviations, so that's the 95% number, but it's only half of it because we're only on this side, not going 2 below. With me? So that's 47.5. And so in this case, we just add those two together. 81.5%. Okay, B. B is use the table to determine the number of values between 73 and 80. So what we notice about 73 and 80 is those are both on the same side. And we'll use that in just a second. So we want to find that percentage. But remember, on the table uses what? What do you look up on the table? The what scores? Z-scores, yeah. So we need the Z-scores of these numbers. Z-score is 73. Remember, Z-score, you take the value minus the mean and divide by the standard deviation. So in this case, it would be 73 minus 72 divided by 3. Right? 1/3. And in the table, they want a decimal, so 0.33, 2 places. 1/3 would be 0.33 in 2 places. Okay, so we look up on the table, and I'll have that table provided. You got it? 12. Yeah, it's on page 690 of this book. So you look up Z is 0.33, and you go to the A. A is 0.129, 12.9%. All right? So we do the same thing with the 80. The z-score of 80. So that would be 80 minus 72 divided by 3, which is 8 divided by 3, which is 2.6, and I'd round that one up to 67. Right? 2.67? Somebody believe that? That's right, yeah, 2. So you look that up on the table there. That would give us an A, 2.67. What we got? 496. 0.496 or 49.6%. Okay, do we add those? Not in this case, why? If they're on the same side, what do we do? You subtract, yeah, you subtract. So 49.6 minus 12.9. What is that? 367? 36.7? Is that right?
I got 33.7.
33.
Oh, it is 36, sorry.
36. Just check. Question or concern? All right, number 10. A little bit of counting. Sounds easy enough. Sometimes on counting, yeah, you just list them all out. But not so on some things. How many committees of 3 can be formed from a club with 17 people? All right, well, remember sometimes we use blanks. Use blanks for each part. Sometimes though we use combinations. So that's kind of, if we're not going to list them, that's one thing we kind of think of. Combinations or blanks. Remember, combinations is when the order doesn't matter, and on committees, does the order matter? No, it doesn't. So committees are combinations because the order doesn't matter on a committee. If it's electing officers, that order matters, and so you use the blanks there. But if the order doesn't matter, you use use the combinations. So this is a combination. N choose R. N is just the number of things there are. So that's 17 people. R is the ones you want to take at a time. So that's 3. This is a combination. 17, 3. And then you just punch that in on your calculator. On mine, I think you do 17, and then go to the combination, which, I cannot find, there it is. 608. All right. Question? B, how many ways can a club with 20 people, and we want to elect officer, president, vice president, secretary. President, vice president, secretary. Well, the thing about electing officers, yeah, let's say I do ABC, is CBA different? That's different, right? So the order matters. The order does matter here, so it's not a combination. When you do committees of 3, ABC, CBA, those are the same. So the order doesn't matter. Same committee for that. This is different officers, because this is A president, B vice president, C secretary. This is a different lineup, right? With me? So this is not a combination. So use the blanks. The order matters, so use the blanks. President, vice president, secretary. All right, so remember how this works. You got 20 people to elect as the president, but what happens? The next one can't be the same person, so it goes down by 1. And then fundamental counting principle says, what do we do with those?
Multiply.
All right. All right, so we got 380 times 19. I get 6,840.
That's what I do.
All right. And then see, one more reminder here of these. How many 8-card hands are there that have 5 clubs and 3 red cards? Okay, so on hands of cards, the order doesn't matter either. You know, you hold the cards however you want. It's still if it's the same cards, it's still the same hand of cards. So the order doesn't matter on hands of cards, so it's combination. However, we want 5 clubs and 3 red cards. 5 clubs and 3 red. So we're going to have to do 2 combinations here. Combination for the clubs and a combination for the red cards. Clubs, there's 13 in each suit, so there's 13 clubs. We want 5. And then over here for the red, there's hearts and diamonds, so there's 13 hearts, 13 diamonds. There's 26 red cards. 3, we want 3 at a time. So those are 13 NCR 5, 1287. 26 NCR 3, 2600. And what do we do with those? Remember, and means multiply. Multiply. And means multiply. So, or means add, basically, and means multiply. So that's 3,346,200. Question?
So on B, if you use the calculator,
Yeah.
that would be that
NCR.
20 P3 on B, on problem B.
Oh, problem B.
Yes.
No, you can't use C. We don't use combinations on
No, I'm talking about 20P,
20P, yeah, you could use P.
20P3.
20P3, yes.
Okay.
Yes, that one you could use permutation on that.
Okay.
But you don't have to, you just do that. Anything else before we go to our geometry? Very cool. All right, so geometry, yeah, there's quite a few there. Remember, so 11A, we want the perimeter of a heptagon, regular heptagon. (13-centimeter) sides. Yeah, so just go back over. A nonagon is 9 sides, octagon is 8 sides, hexagon is 6 sides, heptagon is 7 sides. So just review those terms. 7 sides. So we've got 7 sides, 13 each, so that'd be 7 times 13. Perimeter is just the measure around, so just multiply the 7 times the 13, 91 centimeters. Perimeter. Yeah, B. We didn't do, we can omit that one. I don't believe we did that one. Did we do that one? I don't think we did that one. For some reason. Maybe we did, but we'll just omit it. So I'm thinking we didn't. Okay. Find the measure of each angle. All right, so we've got 2x plus 4 here. This is, just call it A. 4x minus 24, and then B. Get there. So the ones we know something about with the x's, what kind of angles are those? They're just opposite of each other. What do we call that? Vertical? And what do we know about vertical angles?
The same.
They're equal, yeah. So we've got 2x plus 4 equals 4x minus 24. So that sets up our equation. We can solve that for x, however you want to. I'll subtract 4x, and then subtract 4. Gets rid of that, gets rid of that. So we've got negative 2x equals negative 28, right? Divided by negative 2. So that's x is 14. But that's not the answer, because the angle is 2x plus 4. And so if we put in the 14 there, 2 times 14 is 28, plus 4 is 32. And then same thing for the 4x minus 24. 4 times 14 minus 24, that should give us 32 as well. So those are 32 degrees. And what about angle A? Well, if, let's just take this one. If this one we know is 32 degrees, then those two together are 180. They're supplementary. If they're this, you might see this term too, complementary is 90. Supplementary is 180. So those two are 180. So A is 180 minus 32, right?
148.
So that would be 148. And then what about B? Well, do the same thing with B, but it's vertical to A, so it's the same as A. So anyway, remember those on the review there. Uh, 13, shaded area. Okay, so yeah, this, remember your, whoops, it's terrible. That was over there. There are a couple of formulas to remember on this one. The circle is 100 meters across. Okay. And so we're looking at this shaded area. Yeah, so basically you got the area of the circle minus the area of that trapezoid. Okay? You've got to subtract those two areas. All right, so area of a circle, pi r squared. So we got 3.14 if we approximate it there. All right, now, I want the radius of the circle. It's 100 meters across.
So 50.
So it'd be, that'd be the diameter. The radius is 50, yeah. So 3.14 times 50 squared. I think it's 7,850. In the trapezoid, that's 1/2. You do the big B plus the little b, and then times the height. So basically what that means is you add the two parallel sides, so you add the 90 and the 45, and then times it by the height, which is 60. So that gives you 4,050. And so the shaded area is those two subtracted. So that'll be 3,800. And area, remember I'll look for the units too. Area is units squared, centimeters squared. All right, last one on the handout anyway. Yeah, so the last one on the handout is the volume, which so the shape there I've got is pyramid, right? Now, the good thing on this one is the volumes and the surface areas, may ask you about a surface area too, those formulas are provided. I will have those formulas, remember I gave those to you on the test, so I will give you those on the final as well. So, you just have to be able to apply it. And the pyramid is 1/3 B times H for the volume. And B is the area of the base. Now in this case, we've got the base, we've got it drawn out here. This is the base, the bottom. You got an 8.5 height and a 10-inch alongside there. So that corresponds to this. So it's just, I just put the base triangle here for you to look at. Now, area of a triangle, that won't, that's like these. You need to know these formulas. They're pretty common formulas, so you need to know those. So B here is the area of the triangle, the base triangle. What's the area of a triangle formula?
1/2 base times height.
1/2 base times height. So the base of the triangle is 10. The height is 8.5. So you take those and multiply. 52.5. So that's B here. So you got 1/3 and 52.5. Now the height, that's the height of the triangle. I'm sorry, the pyramid.
I think it's 42.5.
42.5? What did I do wrong? Just checking you. No, I don't know what I punched in. 42.5, thank you. And then plug that into the formula, but it's 1/3 the base area times the height of the pyramid, which I've given that to you. The height of the pyramid here is, what I give, 15. So, let's see if I can get this right. Is that 212.5? Remember volume, the units, what do we use for units for there? Cubic units. These are in inches, so it'd be inches. All right. Now the other thing I was going to say was, so I give you the volume and surface area. You need to know triangle area, circle area, those ones. Volumes and surface areas will be given. The other thing that I gave you that you also need, that I'll give you as well, are the argument forms. The modus ponens, modus tollens, remember those? So that'll be provided on the test too. You don't have to memorize those.